So I kind of looked at what you, I guess like a brief CV kind of thing. And it seemed to me that you did your PhD with Rick Hansen, I think, at UCL. Is that correct? Or...
Well, yeah, originally I did it with Mick Rugg, actually. I don't know if you know Mick Rugg.
No, I don't know.
He's more an ERP specialist. But Mick, he left at that time. He left from UCL then to at that time to UC Irvine. He's now in Dallas. And then Rick took me, based me on, I guess. And so I did a lot of my PhD with Rick, yeah.
Okay, so I was just curious because it seemed like when you look at your early publications, it seems like after your PhD you made a switch to dementia work, right? So how did that come about?
Yeah. Oh, yeah. Okay. So the reason, well, okay, this is a long story, I guess. But in essence, so I started a job at UCL with Mick Rugg as a research assistant, and he said, "Well, why don't you do a PhD at the same time?" So that's what I did. But then Mick left to the US, as I said, and Rick kindly took me under his kind of, in his lab. But unfortunately, my job was gone with that as well. And at that time, I didn't have any funding for my PhD. So I literally had to find another job to fund my PhD. So I found a job in the end in Cambridge, and to work much more in memory research, in memory and dementia research. And that suited me really well because there was a strong overlap between that. And that's how I guess, and I should have said for my master's, I did already work in mild cognitive impairment and dementia. So I had already a connection to that. But so this was always these kind of two areas I kind of straddled quite a lot.
Okay, so it wasn't as much of a change as it seems from just the publication history.
Yes, yeah. The publication history is always a very interesting trajectory, isn't it? If I look at some things which I've published, I think I'm not sure I would call myself an expert in that topic. But it's just studies you get involved in, I think, which are interesting at that time. And, it can be a lot of fun, of course, to explore other things.
Yeah, definitely. Yeah, I mean, I think I basically spent like the first few years of my like bachelor's, master's and that kind of stuff just doing different topic after different topic, just working my way through the department more or less. But okay, so as I mentioned before we started recording, I'd really like to talk about Sea Hero Quest, and I actually played Sea Hero Quest a few years ago.
Fantastic! Love to hear that.
Yeah, so maybe my data is in some of the publications. I don't know. I guess
should be.
It might be
Definitely.
Yeah. Well, I guess you can't actually download it anymore, right?
So it has changed now. It's again very, it's a great timing we're talking because the public version of Sea Hero Quest, doesn't exist anymore. However, we have now with our charity partner, Alzheimer Research UK, we've created a new platform which just launched, I think, 3 weeks ago. And that allows now researchers to still use Sea Hero Quest for research studies or for larger studies if you want to. So it's a complete online platform where you can use Sea Hero Quest. And we have lots of people still using it in very different populations. And, studies we would have never dreamt of doing. Lots of people are using it for very different purposes these days, which I think is fantastic and is really exciting to hear.
That's cool. Yeah. So, I mean, maybe for the people who don't know, it's a game where you it's a game, not like an experiment game. It's an actual game that you used to be able to download on the App Store or wherever. And I guess you're like on a little boat driving around the, not ocean, but like rivers and lakes and that kind of stuff kind of thing. And you have to I can't remember exactly, like memorize where things are or find ways. You see a map before, I think, and then you have to find places and that kind of stuff, right?
In essence, well, you're right. This is what it is. It's a game we designed for measuring navigation behavior in people in a game environment, and has different levels. The game, so we have different what we call, I guess, navigation tasks, which are underlying that, which people don't need to know when they're playing it. That was one of the key aspects. When we developed it, I never wanted to develop a gamified experiment, which I've done as well, and that can be interesting. Instead, I wanted to create a game which has valid signs under that, which bizarrely turned out to be the more controversial one. And still, we get a lot of people pushing back and saying it's just a game, without them knowing how much science and how much work is actually under it. Because on the surface, it is a casual mobile game, and that's what it's meant to be. And that's why I think it was so successful, because people love casual mobile games, obviously.
I mean, the number I think is like 2.5 or 3 million downloads or something like that.
No, well, in the end, we had nearly 4.3 million people.
Oh, okay.
Yeah.
Okay.
So we have a huge, enormous data set, and across 160 countries. Most countries, of course, are quite small, but we still have an enormous global representation. But, I think that the whole story started in a way with me going to a workshop to the Wellcome Trust. The Wellcome Trust is one of the large charities here in the UK. And there was a workshop on gaming and science, which I thought, oh, well, great. I have a half day off, go to this workshop, just listen to some interesting things. And this afternoon literally changed my life, I guess, because coming to this workshop and meeting. So at this workshop, there were different scientists and there were different games developers. And for me, at that time, I was already very interested in spatial orientation, spatial navigation.
So when was this roughly?
This was 2015, if I remember correctly. Yeah. 2015. And when I again talked to the games designers, they work all the time in virtual environments. And I thought, well, this is perfect actually for this. So I came really excited back from this workshop, but as always in science, you don't have funding for doing anything like this, and you have to wait for the opportune moment to come. And I think what was really interesting, I received one day a phone call, which was a very strange phone call, because it was somebody saying, well, I'm currently canvassing for a very large corporation, which they didn't tell us at the time, what it was, to do some research into dementia. Do you have any idea what to do? And I first thought really it was a hoax call, like some people just sometimes call me up and wanting to some kind of very strange, kind of either want to endorse their products or anything like that. But I just came back from this workshop and I said, well, what would be really cool would to create a game which could collect science, which could help dementia research. Okay, great. And then the person hung up and said, okay, I might call you back. And I thought I never heard anything. So a month later, and I suddenly get another phone call. Say, okay, they liked your proposal. Can you put together like a 2-3 page proposal? And this will be then a short list, and this will be decided. So I thought, okay, well, now I have to actually think what I'm going to do. And so I started drafting it, then what I thought I wanted. And then I submitted this. And again, I thought I would never hear anything, because at that time I asked them who were the other competitors. And there were some major other places involved in this. And I thought, I would have never a chance against them. And then a month later again, they called me and said, well, congratulations, your project has been chosen. And my first thought was, what am I going to do now? I need to actually come up with something. So my first call was then actually to my good friend and colleague Hugo Spears, who's at UCL. And I said, well, Hugo, do you want to be a lead on this project with me together? You do the navigation side and I do the dementia side, because he knew much more about the navigation aspect than I did. And that's how the whole project really then came together. And it was I think, really bizarre coincidence. And then we found only out that the sponsor was Deutsche Telekom, basically, who did this as their corporate social responsibility project. And it was very, very exciting. And they invited us then for loads of meetings, and they have, of course, they had incredible resources basically, and we could then choose we had a short listing then of games companies who basically tendered for this and made pitches to us. I met some incredible games developers. Then in the end, we decided for one, and then we started developing the game, which was extremely exciting and extremely stressful, because there was a very short timeline. We had to develop the game, finish it in a kind of a 6-month period, which for industry people is quite a long time. But as anybody in research knows, if you start something from scratch, that's actually very, very pressured if you have to come up with everything. And the key, as I said, for Hugo and myself from the beginning was we wanted to create a game that feels like a game, but underneath is science. So not a gamified experiment. And that was the hardest to do. It was a constant discussion between us and the games developers that we would say, no, we can't do it this way. It needs to be this and this and this way. And then the games developers say, yeah, that's all good, but this is really boring. Nobody will play this. And so I think it was this constant discussion, which was, as I said, I've learned so much about games and gamification, and in the end also adding a lot of the elements for Zero Quest into, which had no relevance to the science. So for example, we found out very quickly that people love to personalize games. So in Zero Quest, you can personalize your boat, can have different flags or different colors. It has no relevance at all to the science, but people love it. And so you need to add these. The same with the stars, that you can collect stars. Again, has no relevance to the science, but it is really, really important for the gamification of the, for the game experience, I guess, of the people using it. And that's what they're expecting of a game as well. So it was incredible. And then when it started, then the funders, I remember there was a very awkward conversation when the funders asked us what sample size we would expect to collect which data. And I remember looking at each other and just coming up with this number. Well, we're thinking 100,000 people in Western Europe, because, I don't know, at that time I thought of big epidemiological studies, and I thought, well, if we're hitting that, that would be incredible. And then, but what it showed is actually we completely underestimated the gaming market. And the game was launched in the end in 2016. But now, of course, the gaming market has even bigger grown. But we said we want to collect 100,000 people. We collected 100,000 people in the first 2 days. It was incredible. We were just blown away by this, how big it became, and just snowballed into a bigger thing than we ever anticipated. So, which is really, really exciting. And we had such positive feedback from people. And I can talk a bit more what's in the game, actually. The most interesting aspect has been really more the scientific community, who's been really, really skeptical. And as I said before, who think very often it's just a game, but it's not real science. And that's a really, really interesting aspect, because whether people really accept this kind of using games for science. I personally, I'm a big convert to this, obviously, in a way, and I'd love to do more, but so far we found it very, very difficult to get anything funded through the regular research funding routes, where people would just say, no, this is just not science. And only, with our publications coming out, and there's lots more coming now out, actually, hopefully we can break through that barrier. But I think there's a whole research area to establish, frankly, using games for science.
Yeah, I know that's really interesting. And what I especially find interesting is that it seems, just from what you just mentioned at the end, that I guess this is like the ultimate not exactly someone gives you money to do something crazy, but it sounds like, relative to like, I'm a PhD student. I don't know how grants applications work, but from what I heard is you don't get a call and then 4 months later you get lots of money.
It's very true. It's very unusual.
But it seems like that kind of thing might have been like a really cool starting point for now that you are kind of in the process of establishing these kind of games as a real way to do science, that I'm assuming that in the future, actually, the formal grant giving, so what's the word, like charities or whatever, that they will be more likely to actually fund this in the future based on this like crazy experience you've had.
I hope so, yeah. It was clearly blue sky and high risk. And for Deutsche Telekom, I think it was much more because it was a corporate social responsibility. It was for them a much more public engagement exercise than anything else. And for us, that worked, of course, beautifully, because gaming is great for that. So we, of course, wanted the science to be really solid underneath it. And that was from the beginning, that was crystal clear between Hugo and myself. We need to have really, really solid science underneath it. Otherwise, this is just wasting our time and wasting everybody's time. It's kind of so. And I think that's what we need to convince people, that you can use games and gaming for doing really cool science. And of course, we're not the first ones to think of that. Let's be honest. There are other people who thought already about this and have done very successful. So, for example, Very famous is, of course, Neural Racer by Adam Ghazali from University of California, San Francisco. He was, I think, really the first one, I would say, who created a game for, this is, I think, mostly for children with ADHD to control their or manage their behavior, let's put it this way. And that's been, I think, even licensed now for potentially treatment of ADHD in the US, as far as I know. So he's used that, which is fantastic. And then, of course, there's all these, I don't know if you've ever heard of Folded, which is basically, it's a puzzle game. So people love puzzles and online puzzles, and Folded is how proteins basically build together and protein blocks fit together. It's a very difficult puzzle. And scientists put these puzzles out there, and then the community out there tries to solve these puzzles, which I think, again, is one example. So there are several approaches like this out there. One just really needs to convince, I guess, people that it really makes a difference. For us, it was that I think we took it another level, of course, so that we really wanted people to collect valid data, not only to analyze our data
So a brief question. So this was, as you said, like such a surprisingly huge success in terms of, I mean, this must have been a very big game by gaming standards also to have that many.
That's what we
downloads.
found out, exactly.
How did you do any advertising for this, or how did people find out about this game?
So again, Deutsche Telekom was amazing with this. They had a whole public relations team with that, which really, helped us obviously publish, put it out there. But I think the other key partner we had, which we got on board, was actually then a dementia charity, Alzheimer Research UK. And that really helped us a lot with the credibility. And that gave us the initial push, I guess. But then you could see there was we had this initial push, and then we thought, well, this was maybe it, But we could see then the gaming community itself was picking it up, and it really was gathering momentum. And that's what we didn't expect. And at that time, of course, the whole live streaming of games was still pretty new at that time. Well, not new, but newish, I guess. And
not as mainstream as it is now. Yeah.
And now it's really, everybody, I guess, knows about it. So and then we could see that people were picking this up and we're talking about it and we're saying, hey, this is really, you can, and I think Deutsche Telekom made this very clever that they created this slogan called gaming for good. You can game and at the same time you do something good. Actually, you help dementia research. And that was really great. And people loved that concept. They didn't need to pay for the game and they could play it a few minutes on their mobile and they would contribute to the dementia research. So we could see this was kind of really gathering momentum, and then it was kind of taking itself over. And then you had, of course, at that time, again, influencers were not such a big thing, but we could always see when influencers picked it up and then it basically got another boost. So we were lucky that some influencer, retweeted. At that time, Instagram didn't exist, I think. Retweeted it, and we could see the numbers shot up again. So it's really where these things take their own kind of life. And for us, our sample size, we were already so happy with whatever we had at that stage.
I guess just the first day would have been enough. Just the initial telecom thing.
Exactly.
Yeah. But so just can I ask a very boring question from a practical perspective? How much does it cost to develop this kind of game? Or maybe not necessarily this one, but let's say you want to apply for a new game. How much what kind of what kind of proportions are we talking about here?
And this has changed again, I think. Now these days, it's much cheaper to develop this, of course, because the games engines are much more widely distributed and you can develop it. So it's a very difficult question to answer because it depends a lot what you want to do. So again, I had to learn a lot about this. Do you want to do a 2D game, a 3D game? Do you want a single player? Do you want a multiplayer game? And do you want to have it, standard desktop, VR, AR? All those decisions make a huge difference to the budget. So it's very difficult to put this on, but I think, I don't know. We thought, if you wanted to develop a kind of a 2D, very simple game, you don't need, I don't know, maybe something like £50,000, $50,000, I think maximum.
But if development of the game,
if you want to have a 3D multiplayer game, it would cost you maybe several $100,000. I don't know. You see, it's really just varies enormously how how slick you want it as well to be and how much you want to invest in the graphics and so on.
Yeah, I mean, if I remember, yours was 3D, right? Like yours was definitely 3D and had some complicated or more advanced graphics, but it wasn't multiplayer or...
Yeah, no, it wasn't multiplayer.
Like
we thought about it, but it was just too difficult because you need to, for multiplayer games are a whole another level, I found out, because of course you need to anticipate what other players could do. And within the development framework we had, it was just not possible. And the science, for us, we realized very quickly the science would be very difficult to control what people would do then as well.
Yeah, that's one thing that I was also curious about, like from... I mean, I guess to some extent, you know that people want to get the points and get to the next level and that kind of stuff. But like, I mean, can you maybe just elaborate a bit more on this process between having a fun game and getting actual scientific data out of it? Like, how do you, like, did you already know like what analysis you wanted to do, I guess? Or yeah, kind of how does...
Yes, I think this is how we started really, that we knew we wanted, so for the spatial navigation that we wanted to have certain elements of, allocentric and egocentric navigation. So if listeners don't know what that means, allocentric is usually more map-based kind of navigation. Egocentric is more a perspective or viewpoint-based navigation. And then we also wanted some levels which look more at memory, how people use that. And so we developed, therefore, we wanted different levels who had then different difficulty levels for that, where we would make either for example, the environment more difficult, either a more complex pathway people have to take, or in some levels we had what we call like a fog.
Yeah, that was difficult.
Yeah, which was basically obscuring then the landmarks that people wouldn't see. Yeah. And so these were all manipulations we did in the background, and then the same with the maps. Sometimes we gave people a map before the game, but sometimes the map was half obscured. Again, we wanted to have different, I guess, experimental conditions, I guess, if you want to call it that way, but in a very different way, because we wanted then to modulate the difficulty, and gaming, of course, is perfect for that, because you usually start with easy levels and you go to harder levels. And I think Sea Quest in the end, in total, I think had 54 levels or something like this. The end levels are really, we just had a lot of fun designing the end levels, I remember, because we could just go crazy, literally, because we ran out of ideas at that stage. And we thought nobody would ever play it. But of course, now we know that several thousand people have played. I think we have several 10,000 people who have played the game twice or three times. So we even have repetition data, which is also another kind of a learning effect kind of data, which we also wanted to look at, of course. So this is in the best way how I can explain it. So we started from that framework, and then the game designer started putting together levels and how we would display that, and that it would not feel like just a maze you would have to navigate, but it would feel more naturalistic, but within confines, if that makes sense, like experimental confines.
Yeah. I mean, for example, like the whole boat scenario, is that something where you like figure out, should we do it land, boat, or flying, or whatever, or was it just...
We explored different things. We explored cars, we explored a person, we explored... I don't think we explored airplanes because of freedom. Yeah, that you can move in 3 dimensions. But the boat was in the end turned out, well, we did a lot of user experience then, and the key was that the boat was also the most gender neutral. So the cars, lots of women would never download a car game, for example. We've learned this very quickly from the games people. And this was, again, for us, we wanted, of course, to have a representative data set. You see, this is the other thing. We wanted a data set which could be played by equal men and women. And we have a fairly equal data gender split, actually, in our data, which I'm really happy about. But at the same time, we wanted also to have a good age range, that it wouldn't be the classic only 18 to 25-year-old males playing.
Yeah, and I guess having like a car game does sound like a racing game or something. So that doesn't sound very much like teenage boys basically playing something.
Exactly. Or first-person shooter. While usually, of course, that's what we learned from the games companies. Again, what they showed us from their research is that the women were more interested in more kind of a social aspect and having kind of more a puzzle kind of approach. So we had to think like that as well and really try to find a balance.
So it's a bit of a like adventure puzzle kind of thing.
It is,
right?
exactly.
That's kind of like the vibe we went for.
That's what we came very quickly to, that we wanted to have some kind of adventure game. But again, with the development time, you can't develop a huge adventure game, obviously. So it needed to be quite confined, and we wanted it to be playable on the mobile. And at that time as well, mobile screens were not that, big as you can have them now. So it needed resolution-wise, you needed to also... There were so many, I don't know, I can talk all day about this, because we had all kinds of aspects of also how the data would be saved, how much data would be generated that it wouldn't be too expensive. If people lost connectivity of their mobile, what would happen with the data? So we had all kinds of contingencies in place for that. It was, as I said, it was an extremely steep learning curve, but extremely exciting, I found it.
I mean, I guess this was also, I guess Skype obviously was around for quite a while, but you're in Norwich, right? Or that UCL, and Hugo is at UCL. And the gaming company is, I don't know where, maybe assuming London, but...
They were at that time in London, yeah. And actually, at the beginning, I was living in Cambridge still, so I was at Cambridge at that time still. Yeah, we were having lots of just conversations, basically, day and night, I had the feeling sometimes, and lots of meetings then as well, which most of them happened in London. I just went down to London. That was okay. It's not too far for me to go, but it's, yeah.
As you said, I guess there's lots and lots you could talk about the development, but maybe as one kind of last question about that, is there just anything that you thought basically you had a certain expectation going in and that was just completely blown away? I'm assuming you had some sort of assumption of oh yeah, now I'm going to make this game, it's going to be like this and that. But then when you actually did it, it's like, oh, I don't know, this is something I didn't see happening or expect.
Yeah, I think this was a daily occurrence, frankly, for me, because again, the learning curve was so steep. But I think I really have to give credit to Deutsche Telekom. They really gave us very, free rein. They just told us, we want you to create the best game with the best science. The most discussion and conversations were really with the game's developers. And my expectation at the beginning, I guess, was that we could develop this and it would be fairly, straightforward. But then I learned very quickly that it was far, far more complex. And then the other thing, I think what I completely underestimated as well, and that made me really, really happy, was then that the charity as well, who was on board, insisted that there was a kind of... So it was all enveloped in a story, basically, in the end. So See Her Quest had a story around it as well. And people, while playing the game, could find out more about the story, or they could find out more about dementia. And we didn't realize how impactful that would be, actually, as a public engagement type or exercise. So many younger people who would never talk about dementia because they think it's an oldest people disease. What has it to do with me? They were really engaged with this and they learned so much about it. And I think this is, again, using gaming to reach people, and maybe even, if they not, I don't know how much they contribute to the game, but if they've learned something about the disease and what it is and what it means, I think made it all worthwhile. And I completely underestimated that in terms of comments and feedback, what we got back from people. They really loved that aspect as well, that they could help something, it empowered them to help something and contribute to dementia research, and at the same time they learned something about dementia.
That's pretty cool. To get more to the scientific part, I'm just curious, is there anything that you wanted to test but couldn't? As part of the game thing, something you really went this was one of my favorite things I wanted to test or something, but then it turned out it was super boring to do, or it was too difficult, or I don't know what.
Oh, wow. This is, again, a very good question to answer. I can tell you the first time we actually looked at the data, so we had... the first time we were sent some data from Deutsche Telekom, I remember we were anxiously looking at, because we wanted to find out actually what the data looked like. And we opened the data file and it was empty. And we had nearly a heart attack that afternoon. I remember was one of the worst ever, that we basically ran this huge experiment and there's no data collected. It's such a classic, of course, scientific kind of experience. But luckily we found out that basically something happened on the server, which basically the transfer of the data didn't happen. So it was all there, but I can tell you this afternoon was absolute horror, basically. We thought, oh, wow, we've done everything for nothing, basically. But I think what happened then in terms of, in retrospect here, of course, you always have 20/20 vision. So we thinking back, Hugo and I, we talked about this over all these years. We thought, oh, we could have done this better. We could have done that better. We could have added this. But you don't know at that stage. So I think we were really, really proud how we designed it. And in the end, actually, it delivered more than we expected it to do. So we had a kind of a contingency plan, and which we talked about very brutally honest right from the beginning between Hugo and myself. And we said, okay, so what happens if the data is all basically the timestamp data is not there? What are we doing with the data? What if we don't have any accuracy data? What happens then? What if all the data is garbage? What are we doing then? So we had all these contingency plans, which we built in the game, that we could at least collect a minimal viable data set itself. And that was a really great step, because in the end, it exceeded what we did. And that's always a good place to be in, I guess. And in terms of science, I think after, these 5 years, it's incredible, time flies, we've only really scratched the surface of Zero Quest. It's because it just generated such an enormous data set that you need to be quite careful how you phrase your research questions around it. People always talk about big data. That's great, and it is great, but you need to be very careful which questions you're asking of the big data set, not that you're just finding spurious effects, which, are not relevant really. And that's a really important, I think we discuss a lot. What will be the next, publication on what do we want to look at? What do we have a good rationale for? That's not just by being, completely opportunistic and just analyze, the classic for students, that what we always tell the students, don't correlate everything with everything because you will always find something, that's not good science.
I mean, this leads perfectly to what I wanted to talk about next, which is the actual few papers that have already come out of it. But maybe to start off that discussion, my first question kind of was going to be, how do you deal with a data set that large? Because I'm assuming you had lots and lots of, you could have analyzed independent of, the millions of people you had, but just the data you could get out of each participant, basically. Yeah. How do you approach like a data set this big? Like, I mean, it seems to me that the first few publications that came out were often, it seemed to me the general goal was to establish that this data set is a good data set scientifically.
Yeah, absolutely. Yeah.
So was that the beginning? Kind of like
it was really the beginning that that's what we realized very quickly after the game was launched, that the public reception was really very, positive. The scientific reception was quite muted and quite skeptical. And as I said, it still is in some quarters that people think it's just a game. So we realized very quickly, well, the first thing we need to do is actually look if this is this valid data, literally. And that's what we started. So I think the first, publications are maybe not, for me, I think we're learning so much more about this data that what is, coming out now. So over the next year, we have some really exciting things coming out, which that's where we're really going into, I think, the beauty of the data, where we can really explore what's happening. But it is what you alluded to as well, is at the beginning, we also didn't know how to really go about with such a large data set. So we worked with, computational, we have collaborators who are computational epidemiologists. They know how to work with very large data sets, but it was such a huge data set that very often even they struggled with that. Because not only do we have, of course, single points for each individual, we have time series data, we have all the trajectories of each player. And that is then becomes very, very large. So for us, it was therefore to start very descriptive and try to validate it. And now we're moving much more into the trajectory data. So there's some very exciting work we're doing at the moment with, people who are more mathematicians in particular, who really know how to deal with this kind of trajectory data, or geographers who know more about the environment, how people move through that. And I think that's super exciting. There's some really, really exciting stuff coming out. And I hope that will convince people again that there is something worth in doing gaming and science, I guess.
Yeah, because I mean, as far as I can tell, one of the papers that came out, the +1 paper, was basically seeing whether your gaming relates to real-world navigation. And the answer is yes, it seems to actually measure something meaningful.
Exactly. I think this was a critical question. Lots of people asked us. They say, well, this is navigating in a game. This is completely different to real world navigating. So this is one question we wanted to answer, because which is, it's a very simple paper in the end, but thankfully it showed that, it relates to that. And we expected that to happen. And we've replicated this now in several data sets already. So that's really great.
And then in the PNS paper, you kind of say that we already know that the risk carriers have worse performance. So risk carriers for Alzheimer's disease have worse performance in special navigation tasks. And I guess you test whether that comes out in your data also, right?
Exactly. Again, this was really much more validation kind of paper, because this was the great work by Nico Axmacher's group, of course, who published this in Science, which we said, can we replicate this actually with our data? And we did. Well, and that's really great. If you can replicate a high impact study, that's really, really good. But as you said, we did another paper, which you might not have seen, which looked at retest reliability of CHeroQuest. You see, it's again, not a very exciting kind of research paper, but I think it's really just to show that this is real data. This is not just a game. And it can replicate, itself, and it can replicate other existing studies. And then now we can move to the much more exciting new research, I think, which this game can answer.
Yeah, good. Just to mention for the people who don't know, I have an episode with Nikolai Axmacher about those studies. So if that's interesting, then
yeah, listen to it. He's fantastic. He's amazing.
So, can you say a bit more? If you can't, then that's fine. But can you say a bit more about the stuff that is coming up? But it seems like you're pretty excited about some of the studies.
Yes, it is very exciting, because we get more and more excited by it. I think in general terms, I think it's much more, as we said, in looking at trajectory analysis, how do actually people move through space? And can we potentially predict who is good and poor navigating just from their trajectories, for example? So it goes into very exciting areas. And that in a fairly kind of naturalistic, ecological way. And of course, we want to use that then as well for potential disease prediction in the future, I think. And as I said, this is really, but there's so many, as I said, there will be hopefully, a few papers now coming out over the next year or two, which all look at different aspects, for example, the environment or the memory and so on. We can really now interrogate the data with the questions we actually put there in the beginning. But it took us such a long time, because as it's a long time, but as you say, getting the handle of this big data and understanding this data and then showing that it's valid, those were the first steps. And it just took a long time for us to even develop, the methods, how to look at this. But now I think we're in a really, really good spot. And of course, computational, we're in a different world these days, 5 years later. You can run much more sophisticated algorithms, I guess, on this data set.
So I guess now would be a good time to join your lab. People who want to
please
come in right at the right time.
Please do. We're always looking for people. If they want to join us, we'd love that. I think, we have plenty of data. That's what I always say. There's no shortage of data with us.
yeah, you're probably, yeah. I guess so, as we, mentioned in the beginning, you're kind of, as far as I understand, your main research before doing CHeroQuest was dementia, right? Or Alzheimer's disease. And
it still is, I have to say.
Still is. Yeah. So how does, I don't know, it seems like, are you doing lots of Alzheimer's stuff with the CHeroQuest still? Or is that kind of a separate, you kind of have like two parts to your research now? One is the CHeroQuest spatial navigation in general, and then the dementia stuff? Or how do you think about that?
So I think there was always been a bit of a misconception that CHeroQuest would be used for, in Alzheimer's patients or dementia patients, different dementia patients, but it was never designed for that, because, people who have dementia or Alzheimer's, we have already existing clinical tests, which we can determine them, that's very straightforward. Instead, it's much more about shifting the goalpost, I always call this, that we want to detect people much earlier. And we know, of course, from all the work in the animals, for example, Karen Duff's work and Nico's work, I guess, that, the people who are at risk of dementia, that they're already showing navigation deficits a long time before they develop memory deficits. But at the moment, there are no tests out there for the clinical populations. So a lot of my research is based on these risk groups who are at risk of developing dementia and using CHEROQuest in one element, but we also now develop much more clinical tests, I guess, based on CHEROQuest, and then validated against the big data set, which I think that's really exciting. But then, as I mentioned before, now lots of people use CHEROQuest in completely different populations, which we never anticipated. So we have everything from people, doing intracranial recording while playing CHEROQuest to developmental, to hydrocephalus, to, epilepsy, traumatic brain injury. So many cohorts who use it, which we never designed it for. But what everyone likes, of course, is that the patients, they love it because they don't feel like they're doing a test. They're playing a game. And I think that's really great. Again, even for cognitive rehabilitation, I think, again, the gaming has been completely, some people have tried to gamify that, but I think these are not real games. So there is huge potential still. So we're still collecting an enormous amount of data. We're doing other studies which are more looking at birth cohorts. So people who have been followed up for a long, long time. And if we can use them, or for one aspect we're currently exploring to really do much more work in children. So for us, we haven't really done much work in children with CHEROQuest.
So I have a question that just occurred to me whilst you were talking about different populations. I wonder whether you can look at this or not. One thing that's, I guess, noticeable is that I guess people who are kind of my generation or younger often, I guess I still had in my childhood to memorize a lot how to get from A to B because we didn't have mobile phones where we could just check how we get somewhere. Do you notice like a shift or something in like that the people who basically grew up with mobile phones and never really had to memorize, you never had to like look at a car map and memorize where you had to go. Did you notice like any differences there or?
Yeah, we haven't published anything on this, but you can clearly see how much people use GPS will make a big difference on their navigation behavior. And myself, I noticed this always. I'm a keen cyclist. I love cycling, and if I go a new route and I just look at my navigation computer, I guess, and I just follow the arrow. That's what I do on my bike. I'm not really navigating. But the good thing is you can train it, of course, for people. And that's what we found in our first study, actually, with CHEROQuest. We found that the Nordic countries always came out top in terms of navigation. And what we found out, which we didn't know at that time, is that the Nordic countries, they do a lot of orienteering in school, and they're also always the world champions in orienteering. So people are trained to navigate, and obviously you do then much better at navigation.
I was wondering. I think I looked at the map you had, and I think, or the one of the graphs, and I think Finland was like far better than anyone else or something.
Yeah. Finland, Sweden, and Norway, they were always top in all of these. And the media made this completely ridiculous arguments that maybe because they're Vikings, that's why they're good at navigation.
Because of the seafaring, yeah.
Yes.
Unlike
but then we said, well,
countries.
how about then the British and how about the Spanish and the Portuguese,
exactly.
who were all big seafaring nations?
Yeah. So, so you mentioned that, I guess like the one kind of big problem with Alzheimer's is that, or I guess you didn't mention this, but one of the problems with Alzheimer's, I guess, is that you don't have early biomarkers that much, right? Like, or tests to figure out who's going to develop it later on, but it's more like people have problems and then it's too late to do anything about it. And you mentioned that the spatial navigation problems might occur before the memory problems occur.
They definitely do. We know that. Just to detect them, that's the hard bit, basically.
Okay. So I'm just curious, like how far do you think are you from using anything like not CHEROQuest per se, but something like CHEROQuest as a kind of clinical marker or something like that?
I think we're pretty close, frankly, to this. I think, and I think several groups in the world work on this now. There are several really good tests now out there, which look very, very promising. Now, just to say, we wouldn't, of course, diagnose anybody just on doing kind of a navigation test. And of course, what we see now, there are the blood biomarkers coming out for Alzheimer's disease who look very, very promising. And you can detect, therefore, whether the proteins start to accumulate in the brain. But I think there's no what we call a functional readout. So what does it actually matter, and in terms of the functional changes? And that's really where the interesting, I think, development is. But I think within the next 2 to 3 years, hopefully, we have a great test then for that. And I would be really keen for that to be used as an outcome measure in clinical trials, but also for diagnostics. And then potentially, if you can stop the disease eventually, for some kind of rehabilitation, because it spurred off a whole other research from myself that I got really involved into the other side. Then once people have dementia and they're getting lost. So we did a lot of work in people getting lost once they have the disease, and can we actually predict earlier on who is at a higher risk of getting lost or not? And then can we put better safeguarding in place for those patients?
I see. Okay. So using it, yeah.
Exactly. I think you see there's so many use cases because the area, there's so little done still. So it's an extremely exciting area to work in, which I think, is really fascinating.
So as I said before we started recording, I found out you have a book out a few days ago, I think, or weeks ago or something like that, which is, as far as I can tell, like a general public explanation or overview. This is Alzheimer's disease, something like that. Can you maybe, say a bit more what the book is about, and maybe why you wrote it, and maybe who should read it or who shouldn't, or I don't know.
Well, please do read it, of course.
Everyone, okay.
But I think it's a book written really for anybody who wants to find out more about Alzheimer's disease. So I've done for many, many years public engagement with different groups, and I was always surprised how few people actually know what's actually happening in Alzheimer's disease. How, they don't know why are these specific symptoms occurring in memory and spatial navigation, what is happening to the proteins. And then many people are worried about the genetics, obviously. Can I inherit it from my grandmother? My grandmother had dementia. Will I develop dementia? Those kind of, which I can say because my grandmother had dementia. But, I can tell you the short answer is it's very unlikely. So that's the good news. And on the other hand, you can actually change your lifestyle. Via lifestyle changes, you can reduce your risk of Alzheimer's by nearly 40%. So people don't know that. They're very worried about the genetics, but not about the lifestyle, I guess.
So lifestyle means what, like eating better, exercising, and doing something interesting in their lives? Or?
Yes, I think it's a combination of all those, but a lot of it is down to physical activity. And then that relates to, for example, obesity, insulin resistance, or type 2 diabetes. Then eating well, obviously, and then staying cognitively clearly active is a key aspect for that as well. Sleep as well. There are multiple factors you could actually look at. And in the book, I go through the major ones.
I guess if we're talking about like staying cognitively active in old age, and you have a game about spatial navigation, do any of those games actually do anything that people like?
Well, this is a really interesting question. I had a student working on, actually. I said, can we actually change people's navigation, potentially, behavior, and with that, can we modulate their risk? But I don't have the answer to this at the moment. But it is very interesting because you can actually change people, how they navigate. You can teach them different strategies or keep them cognitively engaged. So I'd love to do a grant on this. As I said, at the moment, I don't have a grant on this, but I think I agree with you. It's a really, really interesting question to look at. Yeah.
But I meant it also more broadly in terms of, when people play like brain training games on their phone or anything like that, does that help in preventing dementia or something like that? Or is that just all nonsense?
Well, okay, so the brain training is still a controversial topic. The problem with most of the brain training programs is that you become better at the actual program, but very little of it transfers to real life. And that's the problem. Where most brain training programs don't show that this transfer or far transfer, what it's really called, into real life is really minimal, basically. We haven't looked at it for HeroQuest, frankly, because we never intended it to be a brain training program, but could do, I guess, in the future. But I think that's where we always say to people, it's better to learn something new. Whatever you can do to learn new, and ideally you combine things. So especially for older people or middle-aged people, combine something which is, you learn something new, which is very social and at the same time maybe gives you some kind of exercise. So, for example, you join a dance class. It's very social. You move. So it's not, of course, you're not running a marathon, but for older people again, that you're keeping active. Or, for example, here in the UK, a very popular thing now is the Walking Football Association. So this is
What's that?
So it's basically there was a realization that lots of older men were still wanting to play football because they love football, but they couldn't because their knees, their back, whatever. So they designed a new league, which is basically in a very small, 5-a-side kind of game played, where nobody is allowed to run, so you can only walk. And this started very small, but now has its own national league. It's huge now, and people love that. And that's great. Again, it has a social element, it has a physical element. And that's, the other thing is, of course, learn an instrument or join a band or anything like that, join a choir. I think these are all things we recommend, which kind of combine these elements, that you have either a social element or physical element or, any of those. It's really good.
So that means golfing is actually the perfect sport for all people.
Well, yeah, if it is for you, perfect. Yes.
I mean, it's social. You're moving.
Yes, exactly. It just depends what you're having afterwards in the clubhouse, I would always say.
Okay, yeah.
I always make this joke to my father, who is a very passionate tennis player for many years, but then he likes the BO2 after that in the clubhouse, which I think, maybe...
Yeah.
It's not so good.
Well, I guess at least it's social rather than drinking at home in front of the
TV. Yeah, absolutely. So the book, was really meant to explain actually in detail this. So I really go into detail how are these proteins actually going wrong? Where is this happening in the brain, and why do they go wrong? What is the genetics? How does it actually work? What are these lifestyle factors? How do they work? And then have two other parts. One is more in the rarer forms of Alzheimer's disease, which people don't know as much about. And then actually the first part of the book is all about the history of Alzheimer's disease. And again, that surprised me for so many years that so few people know actually about the history, about how it was discovered, who these people were, and how, again, how did they come about? And for lots of people, that's a real interest to even most professionals don't know that. So it was a lot of fun for me to go through actually the very historic papers. I went through all the historic papers and really looked at what they actually did. And I love to tell this to my students as well, that when Alois Alzheimer, when he had his first presentation of his first case, he presented this at a conference in Tübingen, to psychiatrists, which were at that time the eminent psychiatrists of southern Germany. And he gave a presentation for half an hour on the case and made even microscopic slices, which he showed and so on. And after his presentation, basically, there were no questions. And he was basically, his presentation was completely flat. So, and because there were no questions, it was not meant to be included in the conference proceedings, which at that time was the main publication. So it would have never made it actually as a publication. And then it was only intervened by his line manager, which was Kraepelin, that it was included. And that's basically that publication from this conference proceeding, which is just 2 pages long, is still the foundation stone of Alzheimer's research. But it's incredible, again, to think about that. He presented this and nobody thought it was of relevance or interest.
It also makes you wonder what else actually was not included.
Yeah,
I completely agree.
I completely agree. And the most even Alzheimer himself doubted this. So his life actually, he became never famous for that. And he always thought these were just some interesting cases, but they were not as special. So I think he himself, he would be amazed that these days it's this major global disease, basically, which carries his name.
And it's one of the main global diseases for all causes of death.
Yeah, top 3.
Right? I mean,
yes,
top 3,
absolutely. After cancer and heart disease.
That's good. By the way, did he name it after himself? Or...
No, he didn't.
Oh, that's a shame. I always love when people name stuff after themselves.
True modesty. No, he didn't. But as I said, he thought it was interesting, but he didn't think it was that special. You can really kind of read this, but it was named, so Kraepelin, who was the main psychiatrist at that time, Alzheimer. At that time, he was in Munich, and he published a new monograph on psychiatric diseases, and he included some of Alzheimer's cases, and he called it, this was the first time it was referred to as Alzheimer's disease, basically.
Okay.
Yeah.
Yeah, you mentioned some rarer forms of Alzheimer's disease, and I think on Twitter you said they also have like different symptoms or something like that. I was curious. So I don't really know, to be fair. What's the difference between dementia and Alzheimer's? And then what are the rarer forms of Alzheimer's, and how are they like, what differentiates them from the main?
Yes, I think it's the most common question I get when I do public talks. What's the difference between Alzheimer and dementia? And so basically you have to think dementia is like an umbrella term, like cancer. But underneath is basically there's several different diseases. And the top is basically the most common form of dementia is Alzheimer's disease, which accounts for roughly 60 to 70% of all people with dementia. And that's why people very often think dementia is Alzheimer's disease. The second most common form is vascular dementia, then dementia with Lewy bodies, frontotemporal dementia, and then there are several others. In total, there are around 15 clinical subtypes of dementia around. Now, the rarer form of Alzheimer's disease, here they have the most common form, or if you might want the classic form of Alzheimer's disease, the protein accumulation of tau and amyloid, the two main proteins responsible for Alzheimer's disease, happens in the medial temporal lobe. And hence, those people have navigation and memory deficits and problems. But for the rarer Alzheimer form, these kind of protein depositions can happen in other areas of the brain. So, for example, there's a form called posterior cortical atrophy, where these changes happen much more in the parietal and occipital areas, and therefore people have much more visual spatial and visual deficits.
Oh, is that the people who have also sometimes like hallucinations or something? Or
rarer hallucinations? That's usually more dementia with Lewy bodies, which is more related to Parkinson's disease. They have very vivid hallucinations. Yeah.
I once met a guy who had like vision dementia or something, and he also just didn't recognize me or something like that. Even though like he could like perform pretty normally, but like recognizing stuff just was
very difficult. And then other forms you have frontal, which are much more called dysexecutive Alzheimer's, where there's more in the frontal, lobes, and they have usually more behavioral and decision-making problems. Then you have one which is called very long name, logopenic progressive aphasia, which is basically a language form of Alzheimer's disease, which is very rare and very difficult to diagnose, actually. And many people are never, get very rarely spotted with that. So you have these different types, which, as I said, you have a very different presenting symptoms, I guess, to the classic Alzheimer's disease.
So from the way it seemed is that, maybe I misunderstood this, but that different kinds of Alzheimer's can affect different areas, and therefore the symptoms are different. Is it then actually a different disorder, or does it just attack different areas of the brain, and therefore the symptoms are different?
It's just because the different areas are attacked, because the proteins are exactly the same.
Okay.
But for other dementias, so you have other, like dementia with Lewy body I mentioned, or frontotemporal dementia, they're caused by completely other different proteins in the brain. And they can affect, again, different areas and therefore cause different symptoms. So it's a bit more complicated. I have this website called dementiascience.org. If people want to find out more, I've always published articles on explaining this. Or, of course, read my book, which is called Tangled Up, The Science and History of Alzheimer's Disease.
Yeah, I'll put a link in the description for the book and for everything we've discussed, papers and that kind of stuff.
As I said, it's written for lay people, but if you want to find out more how Alzheimer's disease is actually, what happens in the brain, I think, I tried very hard to give the essence of it without oversimplifying the science. That's a hard thing to do.
That's a fine balance. Yeah, okay. Yeah, I mean, I'll definitely check out the book. It's in the description for anyone else who's interested. I think I've run through my questions. I don't know whether you have anything to add.
No, I think we covered a lot, haven't we? Yes. I think, in general, I always try to convince people that there is, especially people who work more experimentally, I always try to convince students that it's very, very exciting to work with patients or clinical populations. First of all, it gives your research, it gives a kind of, a real life relevance much more. and you can really make a difference to people. And I really love that. It's very humbling as well for our research, I think, very often. And very often, of course, the patients are real world people. So I see this so often that we get, for example, somebody developed a very clever, for example, cognitive test in undergraduate students. But once you try to introduce that into a clinic, it's very hard because, of course, people come to the clinic, they have very different educational backgrounds, very different backgrounds. You might get very different results. So it's a real challenge always for coming up actually with something which is relevant for those people. But as I said, one can make a really big difference, and that's what really has motivated me. Always this kind of balance between doing exciting experimental research, but then also being clinically or real world relevant. I think that's a really great balance to strike.
Yeah, I agree. There's lots of tasks that are so complicated. It takes like very educated people half an hour to understand what they're supposed to do.
Yeah, yes. Even I struggled with that.
Yeah. I mean, I took part in studies like, what do you want me to do? I still didn't. So, but I guess maybe especially then getting back to the beginning, that's, I guess, especially what these gamified versions might be particularly good for.
I think that's coming back to this, games, I think it's such I don't know, I wish I could convince people more of this, but there's so much potential to use games. As I said, the gaming market is enormous these days. There's an enormous resource out there for people wanting maybe to take part in research or help research or do just exciting things. And people love doing that. If you can develop it and distribute it, of course, you need the funds for that.
Yeah. I mean, I don't really play many games on my phone, or basically none. But occasionally, I have this moment where I'll whatever bored and I'll download whatever game. And I've played like 2 or 3 games where I thought like, if you slightly change this and actually save the data, you could actually do science with this. Like, this is really like, some of them are such cool experiments for like problem solving and
exactly.
like planning and all this.
I think puzzle games are perfect for that, frankly. And I see this all with my children, who of course who play. I don't know, different. They play much more clearly, we do. But and where I see a lot of games where I think, actually, this could be. One could just tweak this, as you say, and make it into something really exciting. Yeah, which I should say. Actually, this is a really interesting tidbit. When we were developing Zero, of course, we had lots of different prototypes, and I would always give my children the prototype to play without telling them that I developed it or co-developed it. And I just
do you think they would have not found that cool if you did it?
Well, I told them afterwards. Okay. But there I wanted their immediate reaction, because children, of course, are brutal in their judgment. And if they would have said this is rubbish, or they said so many times it is rubbish, so we knew we had to change it as well. This was a really great, always a really great test when they were thinking, oh, I'm not sure what I meant to do here. Oh, okay, well, we need to redesign that then,
Yeah. So the kids do come in handy.
Yes, they do. Finally. No, I'm joking, of course.
But yeah, I mean, I hope I'm looking forward to the publications that come out of the Zero Quest thing, and then maybe some cool publications from there will maybe make funders also more likely to.
Yeah, I really hope so. Yeah.